The James Webb Telescope has just announced the clearest image of Proxima B in history, revealing astonishing details about this potentially habitable exoplanet. Join us as we embark on a journey through space to uncover the mysteries of Proxima B and discover whether it could be the next Earth. Let's take off into the vast expanse of space, where a mysterious planet exists in the habitable zone of its star, Proxima Centauri. This planet is not just any ordinary rock. It's Earth's cousin, Proxima B, located a mere 42 light-years away from us. This planet is shrouded in mystery and wonder. Could it be another Earth with oceans and life teeming on its surface? But wait, there's more. Proxima Centauri B is not alone in its journey around the red dwarf star. It has a fellow traveler, Proxima Centauri C. Who knows what other secrets the star system holds? Perhaps there's another companion that we have yet to discover. The mysteries don't stop there. Proxima Centauri B receives just about the same amount of energy from its star as Earth does from the Sun. Could this mean that there's water on its surface? Perhaps even life? As we venture beyond our own solar system, we discover a whole new world of exoplanets. Planets that orbit stars other than the Sun. With 200 billion stars in the universe, the possibilities of exoplanets are endless. Some exoplanets even roam free, tethered to any star, like rogue travelers in space. But among them all, Proxima Centauri B stands out as a truly remarkable and enigmatic planet, with a year that lasts just 112 Earth days and a distance from its star that is 20 times closer than Earth is to the Sun. It is likely that one side of the planet is always bathed in daylight, while the other side remains in perpetual darkness. Now let's talk about Proxima Centauri, the star that Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system. This system includes Rigil Kentaurus, also known as Alpha Centauri A and B, together with Proxima Centauri, also known as Alpha Centauri C. These stars create the nearest star system to our very own solar system. The two stars, Rigil Kentaurus and Alpha Centauri B, form a binary system known as Alpha Centauri A and B. These G and K-type stars appear as one star in the constellation of Centaurus and are the third brightest stars in our night sky, with a peak magnitude of -2.7. Proxima Centauri, also known as Alpha Centauri C, is a red dwarf or M star located 21 light-years away from the other two stars, approximately 13 times the distance between Earth and the Sun. It is technically the nearest star to us. In fact, Proxima Centauri translates to the nearest star in Latin. Discovered in 1915 by Scottish astronomer Robert Thor, Proxima Centauri, despite being our nearest stellar neighbor, is not visible to the naked eye. It has an apparent magnitude of 11.13, which is far greater than the maximum human limit of 6.5. But don't let that fool you. Proxima Centauri is still a star worth marveling at. Red dwarf stars like Proxima Centauri are among the most efficient in terms of energy production. They may not generate a lot of energy, but the internal convection process at their core keeps them glowing for trillions of years. In fact, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still being debated. For one thing, it's a flare star, which means it has frequent and unpredictable fluctuations. As a low-mass star, the habitable zone would be closer to it than that of the Sun, projected to be between 0.23 and 54 cents. But it's not as habitable as it seems. Proxima B is bombarded by extreme ultraviolet radiation from its star, hundreds of times stronger than the radiation we get from our Sun. That's right. It's so intense that even the lightest molecules of hydrogen get destroyed, let alone nitrogen and oxygen. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima B might not have a suitable atmosphere, which is essential for regulating climate and supporting a water-friendly surface. Without it, living organisms will be vulnerable to dangerous space weather, making life nearly impossible. So while Proxima B may look like Earth on the surface, it's far from being able to support life. People have doubts. While there are numerous factors that render it unlivable, the quest to uncover the truth about Proxima B continues, and some people still have hope. One instrument that has captured the attention of astronomers is the James Webb Telescope. After numerous delays, the telescope was finally launched in 2018 and will help us determine whether or not there is life on Proxima B. As with all things in science, things are never quite as straightforward as they seem. Many modifications were required to ensure that the James Webb Telescope produced accurate images. As Avi Loeb, a theoretical physicist at Harvard, explains, if a planet like Proxima B can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope was specifically designed to observe infrared light. It can take photos of this light on the surface of the planet and look for patterns that could confirm whether the planet has water or an atmosphere. But what if the planet has an atmosphere that is not conducive to life? The presence of an atmosphere does not guarantee the presence of life, warns Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a thick atmosphere that is 90 times denser than that of Earth's, and extreme heat that would make it impossible for life to exist. The quest to unravel the mysteries of Proxima B is not without its challenges. While the James Webb Telescope holds promise, there are other factors to consider. With costs mounting, astronomers are hard-pressed to find a way to observe planets like Proxima B. The risks are great, but the rewards are even greater. The chance to glimpse into the unknown and uncover the secrets of a distant planet that holds the promise of life is one that astronomers are willing to take. Traveling to Proxima B, let's say hypothetically, if the exoplanet were hospitable, could we even go there? It's the closest exoplanet to us, which makes it so exciting because it's almost like looking in our cosmic backyard. What's even more interesting is that it's roughly the same size as Earth, and its location in the habitable zone means it could potentially have the conditions for life as we know it. Proxima B's proximity also makes it a prime target for our search for life beyond Earth. With it being just around the corner, well, relatively speaking, it's a great contender for interstellar missions. Imagine the possibility of exploring this Earth-like exoplanet. Though we can't travel there yet, it's definitely on the radar for future missions as technology makes it accessible. It's one of the most exciting projects in the field of space exploration. But getting there is no easy feat. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. However, a solution has been proposed: solar sails. These ultra-thin sails could be used to accelerate a spacecraft to the Alpha Centauri system and Proxima along with it. This technology uses solar pressure to keep the spacecraft on course, eliminating the issue of running out of fuel. And you know what's even cooler? This incredible technology has the power to shed light on the possibility of life on other planets like Proxima B. But as with anything this awesome, there are some limitations. For example, the presence of an atmosphere doesn't necessarily guarantee the presence of life. Proxima B could be like Venus with a thick, hot atmosphere that's not suitable for life. And get this, the James Webb Telescope has the power to detect such illumination if it reaches a brightness of just 5% of the natural dayside. Now, 5% might not sound like much, but when you're dealing with a star that's 20,000 times dimmer than our own sun, it's actually a huge deal. If Proxima B does have an intelligent civilization that's lighting up its surface, they may be using bright orbital mirrors to reflect sunlight from the day side of the planet to the night side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being massive gas giants while others resemble our very own Earth. One type of exoplanet that has captured the attention of astronomers is the gas giant. These planets are similar in composition to Jupiter and Saturn but are much larger. Some of these behemoths have been dubbed super Jupiters, and they dwarf even the largest planet in our solar system. But that's not all. There are also hot Jupiters, which are gas giants that orbit extremely close to their host star. They exist in a fiery world with temperatures that could melt metal. Imagine being able to witness such a planet up close, with its raging storms and blistering heat. In addition to gas giants, there are also Neptunian exoplanets, which have sizes similar to Uranus and Neptune. Among these are the hot Neptunes and mini-Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, with their atmospheres being difficult to study from afar. And let's not forget about the terrestrial exoplanets, which are more Earth-like in their composition and size. These are the planets that scientists are most interested in, as they might hold the best chance for finding life beyond our solar system. The James Webb Telescope's advanced technology is helping astronomers analyze these diverse exoplanets. As we continue to explore the cosmos, we might one day find another Earth or even a habitable planet in the vast expanse of space. The quest for knowledge and discovery is never-ending, and with every new finding, we get closer to answering some of the most profound questions about our universe. As we gaze into the vastness of the cosmos, the discovery of exoplanets offers an unparalleled opportunity to understand the diversity of planetary systems and the conditions that might foster life beyond our own solar system. One exciting development in this field is the advent of new observational technologies and methods, which are enhancing our ability to detect and study distant worlds. For instance, the transit method, which observes the dimming of a star's light as an exoplanet passes in front of it, has been instrumental in identifying thousands of exoplanets. This technique, employed by telescopes such as Kepler and TESS, Transiting Exoplanet Survey Satellite, has significantly broadened our knowledge of planetary types and their distributions. Moreover, the radial velocity method, which measures the star's wobble due to the gravitational pull of an orbiting planet, has also been crucial in discovering exoplanets, particularly those with higher masses. These techniques, combined with advances in spectroscopy, which allow scientists to analyze the atmospheric composition of exoplanets, are leading to a more comprehensive understanding of these distant worlds. One of the most intriguing aspects of exoplanet research is the concept of the Goldilocks zone, or habitable zone, where conditions might be just right for liquid water to exist on the surface of a planet. This zone is defined by the distance from a star where temperatures allow for water to remain in its liquid state, which is considered essential for life as we know it. Discovering planets in this zone is a key focus of current research, as these planets have the potential to harbor life. The study of exoplanet atmospheres is also a burgeoning field. Instruments like the James Webb Space Telescope are equipped with advanced spectrographs that can detect the presence of molecules such as water vapor, carbon dioxide, and methane in an exoplanet's atmosphere. These findings could provide critical insights into the atmospheric conditions and potential habitability of these planets. The detection of biosignatures, chemical indicators of life, remains one of the ultimate goals in the search for extraterrestrial life. In addition to searching for Earth-like planets, researchers are also interested in the variety of planetary environments that exist. For example, the study of hot Jupiters, gas giants that orbit very close to their host stars, has revealed new insights into atmospheric dynamics and heat distribution. Similarly, the study of mini-Neptunes and super-Earths helps scientists understand the range of possible planetary compositions and structures. The advancement of technology is not only enhancing our observational capabilities, but also inspiring new missions and projects. For example, the Breakthrough Starshot initiative aims to send small, light-propelled spacecraft to the nearest star systems, including Alpha Centauri, to capture images and data from potentially habitable exoplanets. This ambitious project represents a significant leap forward in our quest to explore neighboring star systems. Furthermore, the potential discovery of exoplanets with conditions similar to those on Earth raises important questions about the formation and evolution of planetary systems. Understanding how planets like Proxima form and what factors influence their habitability can provide valuable clues about the conditions necessary for life to emerge. Comparative planetology, the study of planets by comparing their characteristics, helps scientists draw parallels and differences among various exoplanets, shedding light on the broader processes of planetary formation and evolution. The ongoing exploration of exoplanets also underscores the importance of international collaboration and the pooling of resources. Space agencies, research institutions, and private organizations around the world are working together to advance our knowledge of exoplanets and space exploration. This global effort highlights the shared human curiosity and the drive to answer fundamental questions about our place in the universe. As we continue to push the boundaries of space exploration and technology, the possibilities for discovering new worlds and understanding the universe's complexities are expanding. Each new discovery brings us closer to unraveling the mysteries of the cosmos and potentially finding other forms of life.